Connection established.
Hi everyone, welcome back to the channel. In today's video, we are again going to cover one important Spark question, that is difference in narrow versus wide transformation. This topic is again very important from your interview front. Through this question, interviewer is trying to evaluate your fundamental knowledge with Spark, right? So without further delay, let's start with the difference in narrow versus wide transformation. So whenever we write any Spark code, right, Spark consists of transformations and actions, right? So what can be the transformation? So say consider one business requirement that you want to read the data set from the SQL Server DP and you want to write the data to your data lake, that is S3. So say you have this typical requirement, and between that you are asked with some business logic addition. That is, say you want to filter out some data set. So say your SQL Server database consists of say 6 months data or some maybe some business codes are there, and you're only interested in some particular business code. So you want to filter out the data set from your input data set, right? And maybe you are asked to write some other business logic. Maybe you want to add some more columns to your data set, right? And say you want to do some aggregations as well before writing the data back to your destination, that is S3. So you have written this particular Spark code, right? So all this business logic which I have discussed, like maybe addition of the column, filtering of the data set, or maybe aggregation, these are all lying as transformations, right? And your final operation, that is writing the data set back to your destination, say S3 or any other destination, is your action, right? So whenever we submit this particular code to Spark, right, Spark works on lazy valuation model. It will create your directed acyclic graph for the code which you have submitted, and then it will divide the code into job stages and tasks. This is again another topic which we are going to cover in subsequent video. But the motto through this example is that where your Spark code consists of transformations, right? Say addition of the column, filtering or joining, aggregations, any n number of transformations you can write, right? So Spark, we internally see which transformations are those which are lying as narrow and which transformations are lying as the wide transformation, right? According to the operation that you have performed, Spark will internally divide that into different stages. So before going further, let's try to see the fundamental. So till now we have seen that how transformations are written in the Spark, right? And then we are trying to know now that which transformations will be categorized as narrow and which are categorized as wide. So continuing our example, see we have read our data set, right? So we doing some Spark.read operations and we get our input data set. So consider this my input data set, which is divided into 4 different partitions. So this is my first, second and third and fourth partition, and this consider this as RDDs, right? So first partition consists of some data values. Similarly, other partitions consist of some other value. So now you are asked to consider one transformation, which is map operation. So you are asked to associate a value 1 with every key present in your data set. So if I have 3 keys here, I want to associate the value as 1, 3,1, 3,1, 9,1. So this is resulting into a paired RDD. Similarly, I will read my partition 2 and I will create another values with 2,1, 8,1. So here through this map operation, what we are seeing that this is my input partition, right? And this is my output partition. So through this particular map operation, what we are getting that each input partition is only resulting into one single output partition, right? Similarly, this partition 2 is resulting into this particular output partition, right? So there is no particular case where a particular output partition is dependent upon more than one input partition, right? So that means this particular operation, map operation or any other operation which we are going to do, which is categorized as narrow, is not going to close the boundary of my this partition, right? This is happening within this partition, reading the value and giving me the output partition. There is one-to-one mapping here. There is no boundary crossing here, and there is a principle of this data locality, right? So this is what is categorized as narrow transformation. So these are the operations where each input partition contributes to only one output partition, right? This is my input, this is my output, and each input partition is only contributing to one output partition. Whereas in case of Y transformation, what is happening? It requires the data from multiple input partitions to compute the result. So to understand this better, let's try to see the example for group by key. So we have reached till now where we are doing the map operation. Now what we are interested to do, we want to group the data based on the key. So if we see we have individual key as 2, then we have 8, 5, 6, 4 and 3 and 9, right? So we have these individual keys. So what we are trying to do is we want to group by key. So all the data for a given key we want to reside in a single partition. So say if I want to aggregate the value for 2, 2 is lying in second partition and 2 is also lying in this fourth partition. So I need to read this both partition, this one as well as this one, in order to get the data set related to key number 2. Similarly, to get the data for key number 3, we want to read the data set from this partition as well as from other partition if it consists of the value for key 3. That means that we are not getting one-to-one mapping here. This output partition, in order to compute its value, it is dependent upon more than one parent partition. It needs to cross the boundary for one single parent partition and needs to move the dataset from different machine. So say if I have this 4 partition, there can be possibility that all these 4 partitions are lying on individual machine, right? Because Spark runs on distributed mode. So there are n number of machines which are lying, and see these 4 partitions are lying across 4 different machines. So in order to compute the value for this particular output partition, it needs to cross the boundary. It needs to read the data from different machine, and the data needs to be moved from one machine to another, right? Which requires a shuffle. Here in this particular case, right, when we are doing the map operations, we are not crossing the boundary and we are not reading the dataset from other partition. Whereas in case of this group by key, we are crossing the boundaries, we are moving the datasets from different partitions and getting the value in a single output partition, which requires a shuffle, right? So if we see that this map operation is a narrow transformation and this group by key is a wide transformation. So if we go back to the definition, so we are saying that wide transformations are the one that requires a shuffle, which we have already seen. Shuffle is an operation where data needs to be moved from different machines or different partitions in order to compute the result, right? Whereas in the narrow transformation, it is not requiring us a shuffle, right? Similarly, narrow transformations are the operations where each input partition, that is this, contributes to only one output partition. Whereas wide transformation requires the data from multiple partitions to compute the result, which we have seen in case of group by key, right? So why wide transformations and narrow transformation? Let's see from the performance implications. So as we see that narrow transformation don't require the data shuffling. So that means no data exchange required from different partitions, right? And so that's why they're more efficient. Because if I don't want to move across different machines, I am saving on the I/O, right? I'm saving on the networking. I'm saving on the compute part. That's why they are more efficient and faster to execute, right? And one of the key characteristics of the narrow transformation is that data required to compute the output. So this is my output, right? And the data required to compute the output for this partition resides entirely within the same partition, right? That is again the same thing. That in order to compute this partition, we are only dependent upon one single partition and we don't need to read another partitions. Whereas in case of wide transformation, this do involve grouping or aggregating data across different partitions and typically leads to shuffling, where data is redistributed across the cluster. So here we see that previously data set are lying across different partitions, and now this data set is redistributed. So the key for 8 here is moving across this machine. So data is now redistributed, right? So here we are crossing the boundary, which is resulting into the wide transformation. Now let's try to understand what type of different operations can lie under narrow and wide. So say, with again the same example that we have quoted in the beginning, you have the business requirement of creating a column. You want to do some filter operations, right? All this case will lie as narrow transmission. Why? So say you have this partition 1 and you are saying that you want to filter the dataset which is greater than say maybe 5, right? So you are only interested in the dataset having value greater than 5. In that case, this will read this partition, and as there is value as 9 which is greater than 5, it will only result into that, right? Similarly here there is this 8, it will result into that. So here we are again seeing in case of filter operation that no dataset needs to cross the boundary. We are reading this single partition and resulting in another single output partition. That's why filter operation, addition of the columns, all those operations which are not crossing the boundary lying as the narrow transformation. Whereas say group by operation, which I have already seen, join operations, whenever you are joining the two dataset, right, it again lies as the wide transformation, because in that case also the dataset needs to be moved across different partition in order to compute the final dataset. That's why the joining, aggregations, right, group by, reduce by key, all these operations requires a shuffle and they are lying as wide transformation. So why we are studying this narrow and why we are studying this wide? Why do we care if these are lying as narrow, why these are lying as wide? Because we have studied the important concept as shuffling as well as the data movement. As we have seen in case of narrow transformation, data across machine doesn't need to be moved. There is very less data movement and there is no shuffling involved, which internally saves in the disk I/O. Similarly, networking, computation, right? That's why these are faster to execute. Whereas, say if if your Spark code consists of more wide type of transformations, right, where there is joining, there is aggregation. In that case, it is very compute intensive. Where your Spark code, what it needs to do, your Spark cluster needs to move the data set. It needs to go to different partition. It tries to read the data set. It needs to move the data set across different machines from networking. It will need to write the data back to some storage in order to save the intermediate storage, right? That will cause your disk I/O. That's why it is more recommended way that if your code consists more of a narrow transformation, then it will be faster to execute. Again, it is not like that you won't use the wide transformation, because if your business logic is something like that where you need to do the aggregation, then you need to write that. It is just like the narrow transformation does not require a shuffle, so that's why they are faster to execute. Whereas wide transformation do requires a shuffle, that's why it will make your code more time consuming to execute, right? So again, similarly here we have written some transformation like characteristic that narrow transformation are fast and efficient, whereas wide transformation are costly due to shuffling. Here we don't need to require any shuffling the data across partition, which we have already discussed, right? Similarly, this can be chained together efficiently with a single execution stage. This particular point is again dependent upon how stages are created inside Spark. But for now, let's understand that if we have some narrow transformation, so say if you have written some 4 narrow transformation, then you have this particular one wide transformation. Again, you have written some 2 narrow transformation, right? So what Spark will do, right? All this 4 transformation, narrow transformation, it will try to reside in a single stage. This particular wide transformation, whenever it say group by, joining or any other wide transformation, it will create another separate stage for that. So all your 4 transformations are chaining together in a single stage where there is no data movement, no boundary cross. But whenever any wide transformation occurs, it will create a separate stage where dataset needs to be moved across different partition. There is a data shuffling, data exchange involved, and then it will try to create a separate stage for that. That's why it's mentioned that narrow transformation can be chained together efficiently within a single execution stage. So all the narrow transformations are lying within the single stage. They minimize the costly network I/O and can be executed quickly by leveraging the data locality. Data locality means the data set is present within the same machine, right? It doesn't need to move across different machines. So that's why the data is local to your execution, and it will save your costly network I/O. Some examples of narrow and map and filter. Similarly, this is wide transformation where we do require some shuffling of the data across partition to fulfill the dependencies. Because the shuffle cause data movement and there are IO involved, they are more expensive, right? Similarly, they will limit the parallelization. Why? It won't be possible that, say, you have another shuffle partition happening here, right? It won't be possible that your Spark code will parallelly evaluate this two shuffle partition, because this shuffle partition is dependent upon another parent operation that you have specified, right? So this will limit your parallelization. Spark will not able to parallelize this two operation, and this will limit your parallelization thing. Again, this is more expensive to recompute in case of failure. So this is related to a fault tolerance, right? So as we have seen that in case of Spark, right, what is happening for narrow where we don't rely on another partition. So what happened in case of say your partition failure? So say your partition one somehow is removed or deleted or something like that, right? And now in case we want to recompute the value for this partition, what we need to do? We just need to find out and recompute this particular partition that is failed, and we will get our final output RDD, right? So that means in terms of fault tolerance, narrow transformations are fast to recompute because we are not relying on more partitions. But consider the similar case for wide transformation. Say this particular partition now failed, and this is my final output partition. Now in order to recompute this, what I need to do, because this particular partition is failed, it might be possible that I might need to recompute this entire output from scratch, because this particular partition can be resulting into more than one output partition. So in worst case, what would happen in case of any partition failure? I might need to recompute the entire output back from the scratch, right? This is what is happening, that this wide transformation, in case there is any partition failure, any type of failure, and we might need to recompute, in that kit it is more expensive because it might need to go through again the same stages like data movement, disk IO, recomputation, and any other thing. So that's why they are more expensive to recompute, whereas narrow transformations are not that much expensive to recompute, right? So that is the difference in narrow and wide transformation, and I hope you get a fair understanding. And in order to understand that, we have this sample code. So this is one word count example which we already have seen, right? Again, one of the fundamental question that is again important. So we have this sample file, right, which consists of some text, right? So we are reading this particular Spark text file through this line, and then we are applying some flat map reduced by key operation. So again, this what flat map is doing, it is reading the entire text and it is splitting that into different words based on the space. Then this map operation is associating the value of 1 to each particular word, because the intention through this code is to count the occurrence of the single word. So first we are splitting the text and lines into different words. Then we are associating the value of 1 to each and every word. So say if I have this transformation we are running, so it will do transformation, 1, v, 1, r, 1, running, 1, right? And finally, we are doing the reduce by key operation, where we are finding the occurrence of the word. So say if D is coming as 5 times in my text, I would interested to get the occurrence as 5 here, right? And then finally, we are doing some collect operation, which is an action which will try to collect all the dataset word count which has happened across the cluster and come back to the driver node, and then we are just printing the value as word count, right? So when we run this Spark code, right, let's try to see from the Spark UI what happened. So when we run this particular Spark code, this is how Spark UI looks like, right? We have different job, different stages. Again, we are going to cover that in the next video. But for high level, what is happening, say, this consists of your different type of transformation. So all map, flat map, reduce by key, all these are the different type of transformations, right? So Spark, what it will do, it will divide your dataset into different stages. So you see there are 2 stages right now. One is this 0 and one is this 1. And if we see the DAG for that, you would see that it will show you the DAG visualization. It will see you first stage and second stage, right? And in the first stage, it is trying to read the text file. It will try to do some RDD, which we have seen paired by RDD, where it is associating the value of 1 to each individual word, right? And in the final stage, because we are doing an aggregation that is reduced by key, which involves a shuffle, right? So what it will do, it will try to read the data set from different partition and try to get the value of a single key in single partition, resulting in a data exchange. That's why you see that whenever we have another shuffle or maybe white transformation, this will result into a second stage. That is what we are seeing from here, that we have two stages here, one corresponding to the narrow transformation, other corresponding to the wide transformation. I hope this topic is clear to you. And if you have further questions related to anything that we have discussed, just please mention that in the comment section and I would be happy to answer that question. Yeah. So for until now, we have covered all the jokes, that is narrow versus wide transformation. So we have already put up different MCQ questions on our YouTube channel. So if you go to our YouTube channel, there is a community section right here, right? So here we have put up like different topics here. There are more than 1,000 questions that are available here in this particular community section. And we have different topics covered from Spark, AWS and other topics, right? So this, we have some theory pasted here. So if in case you want to revise that, like what is narrow, what is wide, you can go through this theory and you can revise your concepts. And after that, we have put up like different MCQ questions. In this video, we are going to cover like some 4 or 5 different questions that are posted on this community section. And I would highly encourage you to go to the community section right here in the Big Data Show YouTube channel and try to solve this MCQ question. This will only revise your concept, because whenever we are just watching the video, it might be case that we will forget that. But in case we are going to attempt an MCQ, it would be highly likely that you will also try to think of the concept that you have learned. So this are very important. I would highly encourage, but this is totally dependent upon you. So let's try to cover some questions. So we have written one question that in Apache Spark, right, we are saying that join is a wide transformation. So we are saying that why might a wide transformation like join be used despite its potential performance overhead of shuffle? So this we have already covered in the video, right? Why we are studying this wide, why we are studying this narrow transformation, right? Why can't we write everything as narrow transformation? We have already discussed, because it all depends upon business logic. In case your business logic requires you to aggregate the data on doing some computation based on this aggregated type of result, combining the data set, it is important for us to use this type of wide transformation. So let's try to see what is the right answer for this particular question. So we have this question and then we have 4 output MCQs here. Just try to read these 4 MCQs, and once you submit that, you will also get the explanation right after this question. So first option is because it is always the most efficient way to combine the data set. This is not the case, right? It is, how can we say that this is the most efficient way? There can be other way to combine the data set. So that is probably that this is the wrong answer. Second option is because it allows for easier fault tolerance compared to narrow. This is again wrong, because we have already studied that narrow transformation in that case, fault tolerance is more easy because we are not requiring shuffling and data movement. So it is easier to recompute. So this is again wrong. Third option is because it is sometimes necessary to combine the data from multiple partitions. This is pretty true. I've mentioned that this can be business requirement where you are required to combine the data set. So you can't just do that thing through the narrow transformation. Also read the fourth option, because it is the only way to perform the aggregation. That is again wrong, because there are other ways to aggregate the data set other than the join. So we are marking third as the right option, and we see that we have written a good Spark theory right here. And in any question, if you see that there is some improvement needed or some theory concept is not right, I highly encourage you to comment on that particular topic. So this will be like a feedback to us, so that we can also improve upon your comment. We have more questions right here. So I'm only picking up the questions which are like more trickier, and I would like you to solve all of the rest of the questions posted on the community section. So next question is, how does Apache Spark execution plan construction relate to narrow and wide transformation? So we studied right from in the beginning of the video that whenever we submit the code to the Spark cluster, Spark will works on the lazy evaluation model and it will create your DAG. And whenever any action is encountered, then only Spark will actually evaluate your execute your code, right? So what is happening that how Spark construct relate to narrow? So let's read the questions. Options. The DAG is independent of the chosen transformation. DAG is built from input RDD to output, favoring the Y transformation. DAG does not differentiate, and DAG is built from output to input, considering the dependency during transformation. So we have seen, right, if I have say 5 transformation, 4 are narrow, 1 is wide, and I have submitted the port to the Spark. So how the DAG will be constructed? So Spark will all categorize all transformations in narrow and wide, and whenever any action, it will then go from bottom to top, right? And then based on different transformations that are encountered, it will divide your code into different stages, right? So in that case, right answer is this, where DAG is built from output to input, that is from your action till your first operation that you have specified, and consider all the dependency that happens and divide your job into stages. So that is what is the right answer for this question. Similarly, let's try to go through this one more question. How does a Y transformation influence the stage creation in Apache Spark execution model? So what is the role of Y transformation and how it will influence the stage creation? As we have already seen in the video as well as in the PySpark code example, that whenever any Y transformation comes, it will ask the Spark to create a separate stage for that, because Y transformation does involve in the data shuffling. So the answer should also be similar to that. So let's see. It triggers the start of a new storage due to the need for shuffling the data row. I think this is the right answer. Yeah. But also try to understand another options and see if that can be a possible answer. It will initiate a new stage by collecting external data. What external data, right? It is releasing data across the cluster. Optimize the data locality eliminating state. This is true for narrow but not for wide. Merges multiple stages to reduce the overhead. This is again not the right answer, because it is not merging the multiple stages, right? It is not the case here. So that's why first option is the right answer. Let's try to cover this last question. What is the potential consequence of chaining the multiple wide dependency together in an Apache Spark application? So again, in the video, we have seen that it is very easy to chain different narrow transformation that will result into a single stage. But what would happen if I try to write one wide transformation back to back? So say I am doing group by key, then I'm doing join, then again I'm doing some group by operation. So I have 3-4 wide transformation back to back. So what would be the implication of all this transformation that I have written, right? So remember when we were discussing the fault order. So say if there is any failure in my parent partition and I want to compute my child partition again, it would again in the worst case scenario recompute my entire transformation from the back, from the scratch. It will result again in the data movement, data shuffling, input IO, all other thing, right? So that's why that can be one of the consequences related to the fault order. Now let's try to see in the different option. It always requires saving immediate result to disk. That is not the consequence. This is the fact. It increases the risk of expensive recomputation in case of failure. That looks like to be probable answer, but let's look at other options. It reduces the overall execution time. That is not the key. If we are chaining multiple byte transformation, it will surely going to increase the time. Another option is it simplifies the fault tolerance mechanism. That is again not the key. It will, if we are chaining multiple byte transformation, it will result into more computation, right? So the right answer in this case is again 3. So this is the right answer, and we have also provided the explanation. So this is all from my end, and if you go to this particular community section, you will see more MCQ question related to this topic. And as mentioned, I will like you to explore this community section and attempt all this question and see your score, how you are doing. And in case you have any feedback for this video or you don't understand any particular thing in this video, do comment and we are happy to assist and happy to answer your question and take the feedback. So thanks for watching the video. Bye.